Hello everyone. From today we are going to start array, and the first question is contain duplicates. So let's read the question first. And given an array integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. So let's analyze what it says. So we are given an array. Let's consider at one array like 1, 2, 3 and 1. Okay, now we have to return if the element present at twice. Like if you consider this element, as you can see, this element appears twice, so this is the same. So we are going to return true. If there is no element, if all the elements are distinct, then we are going to return false. Like if you make this as a 4, now as you can see all the elements are distinct, so we are going to return false. Okay, so how we are going to solve this? Right, brute force approach is that we will fix one element and we are going to check this element and compare this element with it from I plus 1. Like if you consider this I, then I plus 1, we will start checking from I plus 1 up till the end of the list, and if we are getting an element which is equal to this, then we are going to return true. That means there is an element which appearing twice. Okay. Okay, this is the brute force approach. I hope this brute force approach clear to everyone. Like after fixing this, then let me fix this one. Then we will start from here to end of the list. So I'm fixing 2 and I'm checking if 2 is present in this range, range, or like whatever you want to say in this range, then you just return the true, otherwise return, otherwise no, otherwise go to its next element and fix them. Like after fixing 2, then you are going to fix this one and you're going to start checking from here to here. Like this is I and I plus 1. Okay, this is the brute force approach, and the time complexity it will take like big O of n square, because we are using two loops. So let me write the pseudocode for it. Let me write in green. So we will start fixing from I equal to 0, I is less than n, I plus plus. So I indicating that we are fixing one element at I. Okay, now we will start from I plus 1. So j equal to I plus 1 and j is less than n and j plus plus. If my array of I equal to array of j, if this is the case, then we are going to return simply true. If this is not the case and both this loops end, then we are going to return false. So the time complexity in this case will be big O of n square, and the space complexity will be constant. So this is the first approach. Now let's discuss how we optimize this, because it's too much time complexity. So let's move to its optimization. So we can optimize this by sorting this. Like if you sort this, after sorting, array will become like 1, 1, 2 and 3. The same elements come to adjacent, like in this case 1, 1 come to adjacent. So now we will uh, iterate from here to here, and we will check its previous element, like its previous element going to be equal, so we will return true. Then if it is not equal, then we will go to its next element, then I am going to compare this one. If it is equal, not equal, then go to its next element, then compare to previous element. It is not equal, then we are going to return false. Okay, so the time complexity will be like if you use sort, then it will be n log n, and for one loop it will be big O of n, then approximately big O of n log n. Let me write pseudocode for quickly. Okay, so let me erase this thing, and in C++, sort the array. It looks like array dot begin to array dot end. Okay, 1 minute. Okay, after sorting, then I'll iterate from int I equal to 1. Remember, I'm going to iterate from 1, not 0. I is less than n, I plus plus, because we have to compare its previous. And if you start from index 0, like in this case, if you start from 0, then there is no previous, so we will not able to compare this. So I'm going to start from 1. I'll compare its previous, like array of I minus 1 equal to array of I. If this is the case, then I'm going to return true. Otherwise, I'm going to return false. That's it. And I also explained the time complexity as well. So let me erase this thing. Not erase. Let's go to its optimization. How we will optimize this? Okay, so we are given an array like 1, 2, 3, 1. Okay, we can use set. Like what set will do? Like it is storing like a set is store the distinct value, and if you try to insert duplicate value into it, then it will store only ones. Like in the set 1, 2 are present. If you try to insert 1 again, then it will not affected by anything. Like if you try to insert 1, then it present only once. So we are going we'll use a set. Okay, so one by one, I'm going to insert into set like 1. I'll insert it. Then I'm going to 2. Then there is already 1. Then I'll insert a 2. Then I'm going to insert 3. So it will be 1, 2, and 3. This is set. Okay. Now I'm trying to insert 1. Then before inserting every element, I'm going to find like if in the set, if there is 1 present inside the set or not. If there is presence of 1 or any element, then I'm going to return true. Otherwise, whenever the loops end, then I'm going to return false. So let's try to do coding. Okay, so we are going to, and also let me explain time complexity, and time complexity will be big O of n. So because we are running one loop, okay, so we are going to take unordered set int st, let's call it st, and for every element auto it nums, we are before inserting, we are going to ask st.find if there is an element present st.end. If this is present, then we are going to return is not equal to true, and if there is not, then we are going to insert it, and